In this video, we're going to be talking about tournaments. And as you can see here, a tournament, T, we usually use T to denote a tournament like we use D to denote a directed graph, is an oriented complete graph. So remember from the reading that oriented means that you're not allowed to have both UV and VU as an arc. Or in other words, you're dealing with a simple graph, and it's a complete graph. So for example, here the underlying graph of this tournament is K2, right? A complete graph, and every edge has a direction. The underlying graph here is K3, every edge has a direction. Here the underlying graph is K4, every edge has a direction. So these are all examples of tournaments. And the reason, you might guess, that they are called tournaments is they're used to model round-robin competitions like we talked about in video 3. So you might remember the example that we did involved 4 teams, and the graph we ended up with looked something like this. So in general, if you have a round-robin tournament, right, every team plays every other team, so you're going to get the complete graph structure. And then you have some sort of, direction to indicate victory. Now, you don't have to use tournaments in the context of, round-robin tournaments, but I think that's where the name comes from. All right, so what are we interested in for tournaments? Well, a tournament is transitive if whenever UV and VW are arcs, then something else is also an arc. Now, you might remember this word transitive from our video about equivalence relations in a previous unit. If that doesn't sound familiar, you may want to pause this and go back and watch the equivalence relations video just to make sure that we're all on the same page. Okay, but a tournament is transitive, so if you remember, the equivalence relation definition of transitive was if X is related to Y and Y is related to Z, then X is related to Z. So in terms of arcs in a tournament, if UV is an arc and VW is an arc, then UW is also an arc, right? So this sort of completes our chain. Okay, so let's think about what's happening here in a couple of examples. So are the following tournaments transitive? Okay, so we'll start out with a sort of simple one. So remember, to even meet the beginning criteria of this definition of transitive, we need 2 arcs, right, that sort of flow in the same direction, U to V, V to W. Okay, so we need a sort of a path of length 2 to even be able to talk about transitivity. Well, there's only one path of length 2 here, right? V3, V2 and V2, V1 are arcs, right? V3, V2, V2, V1. So the question then is V3, V1 an arc? And if it is, then we'll be transitive. Well, yes, it is. Okay, so yes, it's transitive. Okay, this graph is transitive. So that's sort of the basic idea of what we're looking at. Anytime you have a path of length 2 like this, where you go from V3 to V2, V2 to V1, then you have to close up this edge, right, in the appropriate direction. So that arc has to be there, and it has to be pointing the right way. So you might want to pause the video for a moment and think about whether or not this is transitive. So it turns out that the answer here is no, this one is not transitive. So you may want to think of why not. But I'll give you an example. So for example, V2, V1, and V1, V4 are arcs, right? V2, V1, V1, V4. But V2, V4 is not, and that's not okay, right? So if we go from V2 to 1 to 4, then V2, V4 is supposed to be an arc, but here in our tournament, V4, V2 is an arc. So that's pointing the wrong direction. Okay, so you might see if you can find another one of these. I'm not actually sure if there is another one immediately. But also, let me just point out here, is this a tournament? Is the underlying graph here a complete graph? It is. This underlying graph is K4. I'm not sure if we've seen this particular drawing of it before, but this is K4 just like this is K4. right? We've just sort of like moved one of these vertices into the interior of this triangle. Okay, so that's tournament, whether they're transitive in a nutshell. And what's happening here? We want to have some sort of metric for being able to determine when a tournament is transitive rather than just checking every single possible pair. So to illustrate what's happening, let's just go back and look at this for a second. Anytime you have two edges sort of going in a two-path, what transitivity says is you are never allowed to make that triangle, right? So like a triangle is a three-cycle, and we are never allowed to orient this third edge in the direction that will make this into a triangle. Do you see that? Right? If we go from V3 to V2 to V1, we're never allowed to go from V1 to V3 because we need V3, V1 to be the arc. So it turns out that generalizes, and you may want to think about how it generalizes before I write this in. But a tournament T is transitive if and only if something is true, and it has to do with that idea about the triangles. So it turns out if and only if T has no cycles at all, not just triangles, but no cycles at all. I'm not going to prove this, but let me just give you a quick idea for how it works. So let's just imagine that we had this as part of our graph, right? This was a subgraph for us. Well, if you have a cycle that goes like this, right? Maybe let's draw it a little bit bigger. The idea is that chain has to stop somewhere. You're never allowed to close that loop up, right? Because you can have a big chain of transitivity. So like if V1 goes to V2, goes to V3, then that means by necessity, right, by our definition of transitivity, this has to be there and it has to point this way, right? V1, V2, V3, that means that V1, V3 is there. Okay, and let's just say we add this one in. Okay, well now we have V1, V3, we'll call this V4 and V5. Well, V1, V3, V4 is there, so that means V1, V4, this arc has to be there to satisfy transitivity. Right, but then if we had this cycle around the outside, right, V1, V4, V5 is a two-path, which means that V1, V5 should be an edge, right? We should be pointing this way, which means that we should never have a cycle, right? Always when you get to the last edge, even if the first four are all sort of, I'm looking at the edges or the arcs around the outside, even if these first ones are all pointing in the same direction, you have to flip one of them eventually. Okay, so it turns out that no cycles, that's if and only if. So a transitive tournament has no cycles, and if you see a tournament and realize it has no cycles, then it's definitely not transitive, or then it definitely is transitive. Okay, so these are the same thing. Looking for no cycles in a tournament is the same as knowing whether or not it's transitive. So that's our introduction to tournaments, and the next video will be a continuation. We'll be talking about Hamilton tournaments.